Hi guys, how are you? As you can tell, I don't have a voice. Thank you for being patient. You're going to have to probably listen a little bit more carefully. We are going to be looking at multiplying and dividing fractions today, which I think will be a relief because it's much easier than adding and subtracting. When you multiply and divide, you do not have to find a common denominator. So you simply, when you multiply and divide, you're going to be multiplying fractions by multiplying their numerator across and then multiplying their denominators across. You can, and we'll look at it when we get to a couple problems here. If you want to, before you do the multiplication, you can reduce within a problem. But if not, you can always just simply simplify your answer at the end. But regardless of where you choose to simplify, your final answer needs to be reduced. All right, we're going to go through this and look at a few problems to practice. And again, we have done some of these together in class this morning. I did a brief review, so you can skip over that review. I'm recording the entire thing simply for the kids that are absent so that they have this to look back at. Please remember that your retake for multiplying and dividing fractions is tomorrow. All right, let's look at the first problem. We're going to find the product of 7/8 and 2/3. I'm going to do it two ways. I'm going to multiply just directly across to start, and then I'm going to redo the problem by cross-canceling within the problem, and both of our answers are going to come to the same answer at the end, being simplified. So we're going to start by multiplying the numerator across. 7 times 2 is 14, and 8 times 3 is 24. And by looking at these two numbers, you should notice that they are both even, meaning that they have a common factor of 2. Therefore, we can divide both the top and bottom by 2, and that gives us a reduced fraction of 7/12, and that's our final simplified answer. I can also do, before this starts, I can cross-cancel. Because it's multiplication and division's the opposite of multiplication, I can either reduce within the same fraction or I can reduce across from each other. The only thing you cannot do is reduce within the denominator, reduce within the numerator. You should notice that the 8 and the 2 are both even, therefore they have a common factor of 2. So I'm going to take each one of those and divide by 2. So 2 divided by 2 is 1. I suggest you circle the number so you don't get lost. It doesn't get lost in all of the work. 8 divided by 2 is 4. And now, because 7 and 3 do not have a common factor other than 1, we can multiply across. So I have 7 times 1 is 7, and 4 times 3 is 12. And you'll notice that the answers are equal to each other. So it doesn't matter if you reduce at the end or if you cross-cancel in the beginning. Regardless, you're going to get the same answer. For the second problem, are you able to cross-cancel? No, neither 3 and 4 nor 1 and 5 have a common factor. Therefore, we're just going to simply multiply across. So 3 times 1 is 3. 5 times 4 is 20. It cannot be reduced. Therefore, that is your final answer. All right, I'm going to leave this problem here for you. I'm going to write the answer down at the bottom, but I want you to figure out how you got to that answer. May I suggest, so that you don't have big products in which to reduce, that you cross-cancel to start. Okay, so the final answer here is going to be 2/3. Please do the work to see if you get that answer. All right, and if you need to pause right now and do that problem, please do so. But I'm going to go on to page 10. All right, when a numerator and denominator have a common factor, you can simplify before multiplying, and we've already talked about that. You can simplify before you multiply by cross-canceling. and that's by cross canceling out common factors. Okay? So you should see for the first one that 10 and 2 are both even. So I can divide 2 by 2 and get 1, 10 by 2 and get 5. The 3 and the 1 cannot reduce, so I can simply multiply across, and that gives me 1/15. Alright, I'd like you to do the second one on your own, and I'm going to write the answer down here at the bottom, but you need to figure out and show the work on how you got that answer. Alright, let's scroll down. What if you're multiplying a fraction by a whole number? Well, how do we write the whole number as a fraction? You write it as a fraction with a denominator of, correct, 1. Any number over 1 is itself. So if I write 28 as a fraction, and remember this dot means multiply, it would be 28 over 1. Before I multiply across, you should notice that the 7 and 28 have a common factor of 7. 7 divided by 7 is 1. 28 divided by 7 is 4. So now I can simply multiply across. 3 times 4 is 12 with a denominator of 1, which just would leave 12 as your final answer. For the next problem, I'd like you to try it again on your own. I'll write the answer down in the bottom, but you need to figure out how to get it. Make sure you understand it. Alright, we're going to move on to page 11, and we're going to be looking at dividing fractions. Okay, notice we haven't gotten to mixed numbers for either of these yet. We're just looking at, the fractions. We're going to do mixed numbers in just a second. Okay? Alright, when you divide fractions, if you look at these two numbers here, we have to use what's called reciprocals. And you should recall that a reciprocal is just a flip of the number, okay? Reciprocals are two numbers whose product is always 1. When you multiply numerator and denominator, you're going to get a product of 1. To find the reciprocal of a fraction, you simply flip the numerator and the denominator. It's that simple. So let's look at a couple numbers and what the reciprocals would be. So the reciprocal of 4/5 is 5/4. And if I multiplied those across, I would get 20 over 20. And any number over itself is equal to 1. What would the reciprocal for 12/32 be? It would be 32 and 12. So we don't have to reduce that right now. It's not asking us for the reduced part, it's just asking us for the reciprocal. Alright. To divide fractions, you multiply by the reciprocal of the second fraction. Remember the phrase we use. Keep, switch, and flip. So we keep the first fraction as is. So if we look at A, we're going to keep 3/5 as is. We're going to switch the sign to multiplication. We're going to flip the second fraction. And then we can multiply. So we multiply, there's nothing I can cross cancel, so I'm going to simply multiply across. Gives me 6/5. Is this my final answer? No, because I can write it as correct, from an improper fraction to a mixed number. 5 goes into 6 one time with 1/5 left over. Okay? Let's look at the second one. Again, we're going to keep the first fraction. We're going to switch our sign to multiplication. We're going to flip the second fraction. And then we can multiply across. And if you'll notice, I have a few things that I can cross cancel to start with. The 3's simply cancel each other out altogether. They cancel each other out to 1 if you want to write it. And then you should notice that 10 and 5 have common factor of 5. So the 5 divided by 5 is 1, 10 divided by 5 is 2, and now we multiply across. Our final answer is 1/2. Alright, for the second fraction, if you divide a fraction by itself, and then you multiply it by its reciprocal, what do you think your answer is going to be? Why don't you try that problem on your own and see what you get? I'll bet you will be a little bit surprised. Alright, I'm going to pause here for a second, and then we're going to look at multiplying and dividing mixed numbers. Okay, we're going to look at multiplying and dividing mixed numbers. To multiply mixed numbers, the first thing you have to do is you have to write them as improper fractions. And that's the part that gets a little bit confusing. You can't simply multiply the whole numbers and then multiply the fractions. Once you've changed them to improper fractions, it's multiplying just like multiplying proper fractions. You simply multiply across. Okay? Okay. And then you finally, step 3 is to always simplify. And remember, with multiplication, you can simplify by cross-canceling, or you can simplify at the end by reducing. It doesn't matter. I don't think it's necessary to write these top and bottom like it is for addition and subtraction. But remember, the first thing we're going to do is change it from an mixed number to an improper fraction. How do we do that? Remember, we multiply the denominator by the whole, so that's 10. We add the numerator, so that's 13 fifths, multiplied by 8 plus 1 is 9 halves. And if you look at my fractions diagonally, there are no common factors, which means there's nothing that's going to be able to reduce at the end either. So we're going to multiply across. 9 times 13, well, 13 times 10 is 130. This is 9 less than that, so that would be 121 all over 10. And for a simplified answer, remember, it can't be written as an improper fraction. You have to change it back to a mixed number. 10 goes into 121 12 times with 1/10 left over. And that's your final answer. All right, let's look at the next problem. We have 2 and 1/3 times 4 and 5/8. So we're going to change it to an improper fraction. So that's 6 plus 1, 7 thirds times 32 37 eighths. And I cannot cross cancel across. My denominator, when I multiply across, is obviously 24. 7 times 37. How can I do this in my head? Well, 7 times 30 is 210, and 7 times 7 is 49. And if I add those two together, I get 259. Which is my final improper fraction, but that needs to be changed to a mixed number. It should be pretty obvious that 24 goes into 259 10 times, because that's going to give me 240. So 59 minus 240 is 19 24ths, and that's the final answer. All right, I'd like you to try the next one on your own. And I'm going to write the answer down at the bottom. Okay. We should be done there. We're going to go back, and mine, it's going to be forward in yours, but we're going to look at dividing mixed numbers. Divide mixed numbers, write them as cut first, improper fractions. And now we have a problem that looks similar to one with proper fractions. Now that's multiplication. And remember, our first step is to keep the first fraction, switch the sign to multiplication, and flip the second fraction. Those are our steps. All right, so let's do the first one together. I have 5 times 8 is 40, plus 2 is 42 fifths. Divided by, some of you are accidentally changing that to multiplication before you change flip the second fraction. So I have 20 plus 3 is 23 tenths. So that's my division problem written with improper fractions. Now I'm going to keep the first fraction switch the signs, and flip the second. Now I could multiply across as is, but it's going to leave you with large numbers that are hard to reduce. So may I suggest you notice that 5 and 10 have common factor of 5, which would leave you with 1 and 2. And therefore now when I multiply across, I won't have numbers that are so large to deal with. So 42 times 2 is 84 23rds. And I have to change that to a mixed number. 23 goes into 84 3 times, and that gives you 3 times 23 is 69, so I'm going to minus 69. And 84 minus 70 would be 14, and I'm going to subtract one more, so it's going to be 13, correct. Actually 15, sorry. So then I have 15 23rds. 23rds a prime number, so you're not going to be able to reduce that. All right, let's look at B. Again, first thing we're going to do is change them to improper fractions, so that gives me 21 fourths divided by 7 halves. I'm going to flip, so I have 21 fourths, keep, switch, flip the second fraction. Let's look if we can cross-cancel. And this one's a gold mine. We can cross-cancel twice. 7 cancels itself and goes into 21 3 times. 2 and 4 have a common factor of 2, which would give you 1 and 2. And now when you multiply across, that's going to give you 3 halves. 2 goes into 3 one time with 1 half left over. All right, I'm going to leave, well, I'm actually going to do letter C with you. What do you do again if you have a whole number? Correct, you write it as a fraction over 1. Okay, that's an improper fraction because the numerator is bigger than the denominator. And I'm going to divide that by 1/9. So I'm going to keep, switch, and flip. Simply multiply across. That gives you 99 over 1, which would simply be 99. For this last one, I'm going to help you set up the problem, but you are going to solve it, and I'll put the answer down at the bottom. Joanne has 3.5 yards of material to make costume. Each costume takes 2.25 yards. How many costumes can she make? So we are going to take this total amount of fabric and we're going to divide it into equal parts of 2.25 yards. So we're going to take 13 and 1/2 and we're going to divide it by 2 and 1/4. All right, so please pause, try this problem on your own, and I'm going to put the answer at the bottom. All right, guys. Remember, you have a retake tomorrow. Good luck on that, and that's it. I'll see you later.